Hi everyone, welcome to this channel. Today we are going to talk about the concepts of an operating system. Let me start by defining an operating system so that we can understand its definition, followed by the concepts of an operating system. An operating system is a system software that manages computer hardware, software resources, and provides services for computer programs, acting as an interface between users and the hardware. Four general roles of an operating system. We have process management. The operating system controls running programs or code processes. It starts and stops them. It also shares the CPU among them. Memory management, which is also a role of an operating system. Operating system keeps track of what part of memory is being used by which program. Also makes sure programs do not use each other's memory by mistake. File management. The operating system helps store, organize, and manage data in files on storage devices like hard drives or flash drives. The other role, device management, which is the input and output devices. The operating system controls how the computer uses devices such as keyboard, printers, and disks so that they work properly. Why these roles of an operating system are important. We talked about process management, memory management, file management, device management, these four roles. So these are the roles we are going to talk about. Why are they important? Process management makes sure the computer can run many programs at the same time without problems. So the role of process management is manage, run processes which are running programs. So process management makes sure the computer can run many programs at the same time without problems. Memory management prevents one program from destroying another program starter. Memory management prevents one program from destroying another program starter and makes good use of memory. File management keeps files safe and easy to find or save. Device management ensures smooth communication between hardware, devices, and programs. In an operating system, we can have this condition which is called rest condition. So we want to know what is it. A rest condition occurs when two or more processes or threads access shared data simultaneously, and the final outcome depends on the order of execution. So in a rest condition, we are saying two processes are sharing the same data simultaneously, and the final outcome depends on the order of execution. Let's see the example. Suppose two threads, thread A and thread B, both try to update a shared variable balance 100. Thread A reads balance 100 as 20 and writes 120. Thread B reads balance 100, subtracts 10 and writes 90. If both execute at the same time without synchronization, the final result may be 90 instead of 110, depending on which thread writes last. This unpredictability is a rest condition, often avoided using synchronization mechanisms like semaphores or matrix locks. We can have a deadlock situation in an operating system. A deadlock situation is a situation in which two or more processes are permanently blocked, each waiting for a resource held by the other, and none can proceed. Also, we can have starvation. Starvation occurs when two processes, let me start. What is starvation? Starvation occurs when a process is continually denied necessary resources because other processes are always given priority. So in this one, we are saying a process is continually denied the necessary resources because the priority is given to other processes. Let's look at the difference between these two, deadlock and starvation. Deadlock processes are stuck waiting for each other's resources indefinitely. Starvation, a process waits for a long time due to resource allocation bias. Deadlock, secular waiting for resources. Starvation, poor scheduling or priority policy. Deadlock involves two or more processes blocking each other. Starvation may involve a single low priority processing. Deadlock needs detection, prevention, or recovery mechanism. Then starvation can be resolved by fair scheduling, e.g. aging. Now we are going to describe the 4 general strategies for dealing with the deadlocks. We have deadlock prevention, deadlock avoidance, deadlock detection, and recovery. Ignore the problem. Let's start by deadlock prevention. Design the system so deadlocks never happen. For example, make process ask for all resources at once. Deadlock avoidance. Check every request and only allow if it is safe, e.g. Banger's algorithm. Deadlock detection and recovery. Let deadlocks happen, but detect them and fix the problem. E.g. stop one process to free resources. Or ignore the problem. Some systems don't deal with it because it happens very rarely, common in home computers. Right? In the context of an operating system, we can have what we call consumer problem, producer-consumer problem. We want to know what is it. The producer-consumer problem is a classic synchronization issue where the producer generates data and places it in a buffer. The consumer retrieves and uses data from the buffer. So the problem arises when both access the buffer simultaneously, these two, producer and consumer. The producer might add data to a full buffer, or the consumer might try to remove from an empty one. Synchronization tools like semaphores or mutex locks are used to ensure safe access to the shared buffer. So in this condition, we are saying producer and consumer share the same buffer. The producer adds data and the consumer uses data. So in this context, a producer may try to add data to a full buffer, or the consumer may try to take data from an empty buffer. Let us have an example so that we can understand this. Given this example, in a print spooler, the printer, right? The producer is the application sending print jobs. The consumer is the printer that processes the jobs. If not synchronized, the producer may try to print from M to PQ, or the producer may overload the buffer. I think that's all about what we call the concept of an operating system. So I think this is the end of this tutorial. Thank you.